Hello again, everybody. This video is going to cover the solutions to Quiz 3. We're in the spring 2023 semester. This is Math 302 at Cal State Fullerton. And in this video, we cover the first problem. This problem is going to be looking at the well-ordering axiom. So we're asked to criticize the following misapplications of the well-ordering axiom. Now, before we get into those, maybe it's a good idea to write down the well-ordering axiom. Now the code word I use here, or the code symbol WOA for well-ordering axiom, and we're looking at the greater than or equal to 0 version. And this says that every non-empty subset of the non-negative integers has a least element. All right, so let's take a look at these two statements and see if they violate the well-ordering axiom. So the first one, if S is a subset of the non-negative integers, then by the well-ordering axiom, S has a smallest element. Okay, they used the word smallest. Remember, this was another word we could use, smallest element. We even said a minimal element. That was fine too. Well, boy, this looks like it's almost the same thing, except for one word is missing. Every non-empty subset of the non-negative integers has the least element. If you have the empty set, that is a subset, it certainly doesn't have a least or a smallest element because it has no elements at all. So that's the missing piece here. This just said S is a subset, but what we need is a non-empty subset. All right, now let's see. B. Let S be a subset of the non-negative integers. They still didn't say non-empty. Oh, but wait, assume that S is not empty. Phew, okay, so it's not the same problem. Since 0 is the smallest integer, by the well-ordering axiom, 0 is an element of S. All right, so this is a common misconception that a lot of students will have, that, oh yeah, look, we're looking at z greater than or equal to 0. 0 is the smallest integer. So if I have a non-empty subset, 0 is the smallest element. Of course, this is easily disposed of by just looking at an example. For an easy example, consider, I don't know, how about S equals the set containing just the number 1. This is a subset of the non-negative integers. It has a least element. WOA greater than or equal to 0 promises you that it will. But that least element is not 0, right? It's 1. So it is absolutely false that you always have to have 0 in a subset of the non-negative integers. Just because 0 is the smallest element in the non-negative integers doesn't mean that it's in every subset, right? You can have smallest elements that are not 0 as long as they're just, well, sets that don't contain 0. All right, so those are a couple of very common mistakes that people make using the well-ordering axiom. You need to make sure your subset is not empty, and no, 0 doesn't actually have to be in every subset of the non-negative integers. All right, we'll see you next time with problem 2. It's going to look at some divisibility questions.